Class 8 Science, Chapter 13 Sound, and in this video we will discuss about amplitude, time period and frequency of a vibration, and we will also discuss about loudness and pitch of a sound. First come to amplitude of a vibration. What is vibration? The to and fro motion of an object is known as vibration, and this vibration is represented like this. Okay, this is ball hanging to this place. When this go to this side, when go to this side, okay, this is to and fro motion. This is vibration, and this also represent the vibration. Okay, this motion, that is vibration, is also known as oscillatory motion. Okay, then how can we say that one oscillation is completed? Just say this one. This condition, that is, this is a center position. Okay, when this ball move to this side at its extreme distance, okay, and again pass this center position and in the another side, if it again going to the its extreme distance, and then again once come to its center position, this, then we can say one oscillation is completed. Okay, then what is this amplitude? During this oscillation, the distance from this, that is center to the extreme, this one, center to the extreme, either this side or this side, this is called amplitude. You can see the distance from the center of motion to either extreme, that is called amplitude. You can also understand this amplitude if we consider the motion of this spring. Okay, this is our center position. Okay, and when this is the extreme distance in one side and this is the extreme distance in another side, we can say this is from this to this, this is called amplitude. Okay, now time period and frequency of a vibration. First come to time period. The time for one oscillation is called time period, and it is represented by T. Then how much time is required to complete one oscillation, that is called time period. Frequency, the number of oscillations per unit time is called frequency, and generally this unit time we will consider as 1 second. Number of oscillations per second, that is called frequency. And frequency and time period are reciprocal to each other, and they are represented like this. Frequency is equal to 1 by time period. Okay, frequency is expressed in hertz. Its symbol is Hz. A frequency of 1 hertz is 1 oscillation per second. If an object oscillates 20 times in 1 second, then what is its frequency? We can determine frequency by using this formula: number of oscillation divided by time taken, that is 20 divided by 1, that is 20 hertz. Now, amplitude and frequency are two important properties of any sound. We can differentiate sounds on the basis of their amplitudes and frequencies. Okay, this is and. Now, loudness and pitch of a sound. Consider one activity. Take a metallic tumbler and a tablespoon. That is, we have to take one glass and one chammach. Strike the tablespoon gently at the brim. Brim means kinara of the tumbler. Hear the sound produced. Now, bang the spoon on the tumbler. ओके, ये टम्बलर पर अब स्पून को ठोकना है, जोर से बजाना है, एंड हियर द साउंड प्रोड्यूस्ड अगेन. व्हाट वी विल ऑब्जर्व? वी ऑब्जर्व दैट साउंड इज लाउडर व्हेन द टम्बलर इज स्ट्रक हार्ड. ओके, दैट इज इन दिस सेकंड केस साउंड इज लाउडर. नाउ सस्पेंड अ स्मॉल thermocol bowl touching the rim of the tumbler like this figure. This is metallic tumbler and this is thermocol bowl, and this is suspended within our hand in such a way that this touch to this one. Okay, now vibrate the tumbler by striking it. observe, what will happen? Ball is displaced. Okay, as soon as we struck this tumbler, this will displace. Okay, that displacement of the ball is measure of the amplitude of vibration of the tumbler. Now strike the tumbler gently and then a little harder. We will observe that when we strike the tumbler gently, this thermocol ball displays less. But when we strike the tumbler hard, then this displacement will be more. That's why we can say the amplitude of vibration of the tumbler is larger when the glass is struck hard. Thus, the loudness of sound depends upon the amplitude of vibration. Okay? Loudness of sound is proportional to the square of amplitude of the vibration producing the sound. For example, if the amplitude becomes twice, the loudness increases by a factor of 4. The loudness is expressed in a unit called decibel. Okay, and its symbol is small d capital B, dB. And this table representing the loudness of sound produced by the different sources. Normal breathing 10 decibel, soft whisper at 5 meter, whisper means फुसफुसाना 30 decibel, normal conversation जो normal हम बातचीत करते हैं, loudness is 60 decibel, busy traffic 70 decibel, and factory, that is sound produced by the average factory, this is 80 decibel. Okay, above 80 decibel the noise becomes physically painful. The loudness of sound depends on its amplitude. When the amplitude of vibration is large, the sound produced is loud. Clear? And when the amplitude is small, the sound produced is feeble, kamjor, halki. Clear? Sound of a baby is different from that of an adult. Even if two sounds are equally loud means have equal amplitude, they differ in some way. Okay, in what way they may differ? Another property of sound, that is frequency. The frequency determines the shrillness or pitch of a sound. Shrillness means tikshanta or sur of a sound. If the frequency of vibration is higher, we say that the sound is shrill and has a higher pitch. Okay, higher frequency means higher pitch. If the frequency of vibration is lower, we say that sound has a lower pitch. For example, a drum vibrates with a low frequency. Therefore, it produces a low pitched sound. On the other hand, a whistle has a high frequency, therefore produces a sound of higher pitch. In this diagram, you can see this is drum, and this represent, we can say what is the frequency? Frequency is the number of oscillations per second. Okay, now in this case the distance between this oscillation is increased. That's why number of oscillations per second will decrease. Hence low frequency, it means low pitch. Okay, now in this case these sound waves are close to each other. That's why we can say number of oscillations per second increases. That's why high frequency and higher pitch. Clear? A bird makes a high pitched sound, whereas a lion makes a low pitched roar. Okay, however the roar means the harna. Roar of lion is very loud, while the sound of the bird is quite feeble. Now again correlate, that is loudness with the pitch. Loudness with the pitch. We can say for lion the low pitch sound, but loudness is very high. Clear? And in case of bird, that is high pitch sound, but this is quite feeble. That is, we can say loudness is small. Frequency of the voice of a child is higher than that of an adult, and usually the voice of a woman has a higher frequency than that of a man. We can say the voice of man is loud, while voice of woman is high pitched voice, high pitched sound. Clear? You can also understand this one. If we consider that the sound waves travel like this, these are the waves. Okay, and this is the mean position. Then we can say this distance, this is called amplitude. Now in this case, this amplitude is small, that's why this is feeble sound, loudness is less. And now in this case, this amplitude is higher, that's why we can say this is louder sound. Now in this case, this the frequency, in this case frequency is small, that's why this is lower pitch sound. In this case, this is frequency is high, that is higher pitch sound. Okay, thank you. Subscribe my channel to get the next video from this chapter.